Howdy there, Internet students. It's Mr. Hermanson again. Say this is day 2 of looking at functions. Today I'm going to introduce you to function notation. Just pay close attention. It's not a real big deal, but there's one thing a little bit confusing about it. As soon as you got that figured out, you'll be good. So move to page, I think it's somewhere around page 13, right here. Page 12. Function is a rule that takes an input, does something to it, and gives it a unique corresponding output. You guys, the fact that there's a unique output is what makes it a function. You can't have more than one output for each input. And we use notation that looks like this. And what we say is f of x, and actually that's just a really short way of saying the output when the input is x. Okay, so it's actually shorthand for doing input-output rules. All right, so if you remember that, it's not that big a deal. But if you see, so here's our function rule, and we want to find f of 2. All that's saying is put 2 where the x is and find the output. So notice we replaced the x in the function with the number 2, simplified it, found the answer. Okay. Same with this one here. We put -3 where every x is in the function. Simplified it, found the answer. All right, here's a couple more examples. Functions can have other names like g, any letter actually. But just remember this parentheses does not mean multiply. It's just identifying the part that is the input. Whatever's in the parentheses is the input. So x is the input, and then the output is the function rule g of x. All right, and here's an example of finding the output when the input is 2 in both of these two different functions. All right, so let's do some problems. So just remember f of x does not mean f times x, and then you'll be good. Okay, so this one here is on your homework. I'm going to let you figure that out and then put it on there. But I'll show you how to do one of these. You can try one, and then you should be good to go. So our rule we're using is 2x minus 3. So what I'm going to do is put 7 where the x is. So find the output when the input is 7. So I'm going to do 2 times 7 minus 3. 14 minus 3 is 11. So we can just, in shorthand, when I write this, f of x equals 11, I'm saying the output is equal to 11. Why don't you try this one, and I'll give you the answer. See if you got it right. You should have got -11 for that one. Okay, on this one, we have a new function. This is our k function. We're going to multiply -7 times x and then add 1. So I'm going to do, to find k of -1, I'm going to do -7 times -1 and then add 1. Well, that equals 8. Okay, you try k of 5. I hope you got -34 for that one. Okay, sometimes you're going to have more than one x. No big deal. You just have to put your input value, which is in your parentheses, in for every x. So I'm going to do 5 squared minus 3 times 5. And then add 5 to that. Well, that's 25 minus 15 plus 5 equals 15. All right. This is a little different function, but I'll let you go ahead and try p of 1, and then these two again you're going to do on your own and submit your answers on the homework. I hope you got a 3 for that one. All right, I'll just do the first one for you, then you're going to graph it to decide what type of function is this, whether it's a linear function or a nonlinear. The answer to this you're going to put on the Google form for your homework. But so we're just inputting this -2. So basically I'm finding f of -2. So I'm going to do 5 times -2 minus 3. I'm using this function here. That's a 3 there, by the way. And that's negative 10 minus 3 is negative 13. So you're going to fill in the rest of those, graph them, and help you decide what kind of function that is. Do the same thing with here. I'll do the first one with you. We're using this is a different rule. I'm finding f of negative 2 right here. So I'm going to put negative 2 where the x is as the power, and then add 5 to that. Remember, a negative power, that is 1 over 2 to the positive power, which is 1/4. And so it's 5 1/4, or 5.25. All right, I'll let you finish that up. A function can be a table of values. Okay, so these are the inputs on top, and these are the outputs. You can think of them as like x and y. Okay, there's ones on the left side you're going to do for your homework, but I'll help you with this one here, B. So if we're saying that the input is 20 when we write it like this. So I want to look for 20 where x is, that's where the inputs are. So I go right here where 20 is, and I find the output for that, which is 0. Why don't you go ahead and try this one, see if you get it right. You probably were wondering, what the heck? But -1 is not one of the inputs. So we do not have this function defined for -1 as an input. Do not think that it's this in here, -1 is the output. Okay. Now here we're given the output because we're told f of x equals 9. So for these problems, we want to find this value in the output row, which is right here. Now this one has kind of an issue. There's 2 of those 4s, which means x is 2 different values. It's 9 and 8. Go ahead, you try this one. That one's undefined again. We do not have an output of -5, so we can't solve that. Anyway, okay, sometimes you will be given the output and you have to find the input. So that's what we're doing here. Again, I'm going to have you do these 2 for homework, but I'll do this one. So we want to find x when g of x equals 11. That means that we're going to put 11 for our output. And then we're going to figure out 3 times what number plus 2 equals that 11. And so I'm going to do 11 minus 2, which is 9 divided by 3. And I get x equals 3. All right, see if you can do this one. I got 10 for that one. All right, sometimes the function rule, well, usually we create functions to represent real values. In this one, J is our input, and J is the amount of juice that you drink, okay? So you start with a 20-ounce bottle, you drink juice, and the height is the output of the juice if you look at the clear bottle. So you have some bottle here, right, of juice, and this height of this juice, every time you drink an ounce, the height decreases by 0.3 inches. All right, so what we're going to do is make a table of values for this, and we're going to use J as our input, and then our output is the height function rule, h of j. So let's just go, you know what, let's try and think of what would be good value. I'm going to go by 5 ounces at a time. Not exactly sure why, but we'll see if this works out. Yeah, that worked pretty good. I'm just multiplying 0.3 times my j values, and then subtracting that from 6. And we find that when we get to 20 ounces, we're down to 0. So we just figured out that it takes us down to 0 when we have an input of 20 ounces. All right? And then you could graph that. I think I would go by 5s on the graph also, maybe, down here. 5, 10, 15, 20. And then on this graph, we need to get up to 6. So I don't know if it works to skip like that. Not quite. Oh well, we'll put 6 up there. So we're starting at 6, and then you can go ahead and graph those in there. Okay, I'll let you do the next one. All right, there's a table of values for that. A function rule can also be represented by a graph. Okay, and you just have to know what you're looking for, which axis is which. The input is the x-axis, so that would be the time. So on a problem like this right here, you would be trying to find the distance at 5 hours. Okay, so you would just go to 5 and go up here and then go over to the distance axis and say 11 for that one. Go ahead and try this one. You should have got 0 there. You might have noticed that that it represents the miles away from where Gulliver started. So basically they're saying he's back in 10 hours, he's back to where he started from. Now down here we're trying to find the distance. When the distance is 2, what is the time input? So I'll do this one with you. So on this one we're going to look for 5 as the distance, and then we're going to go to the graph. Now for this one there's actually 2 answers. There's 2 times when Gulliver is 5 miles away from where he started. One is at 4 and the other one is at about 8.5. Okay, why don't you try this one here? You should have 2 different answers. One answer is actually kind of a range. At 4 hours, it looks like or at 4 miles, right here, he's between 2 and 3 hours. So he must have taken a break in there, like for lunch or something, or to look at sites, but whatever. And then this one over here, I just guess that's about 8.75. Can't be exactly right on that. All right, that's all I'm going to go over with you today. You can go ahead and do the Google form, finish up the problems that I didn't do with you, and then submit your answers on the Google form. If you have any questions, let me know. Talk to you soon.